going to take a look at factoring trinomials. And what we noticed here in the past, we have multiplied two binomials and they've given us a trinomial. And when we did this multiplying, we did FOIL. We did x times x, that's first, that gave us x squared. And then 2 times x gave us our outer, that's 2x. And inner was 6 times x, that gave us 6x. And then last was 6 times 2, and that gave us 2 times 6. And then what we did is we combined our outer and inner together to give us that 8x. And we multiplied these things. So that's x squared plus 8x plus 12, and that gave us our trinomial. When we go in this direction, we are multiplying. If we give you a trinomial and we want you to break it into its factors, so you're going to put it back into two binomials that are multiplied to each other, those are called factors. That process is called factoring. So when we go to factor our trinomials, we can think backwards FOIL. So you're going to start with ax squared plus bx plus c. And that's what we say for the trinomial. So the number in front, or the coefficient in front of the x squared, we're going to call it a. The coefficient in front of the x, we're going to call b. And the number that's just by itself, the constant, we're going to call c. So I'm going to, my first step will be to list my factors of c. My second step will be to find the factors of c that sum to equal b. My next step will be then to fill in my parentheses, and my fourth step will be to FOIL, and I can check my work by FOIL. So let's take a look at an example because that's how you see it best. So my first step, here's my example, x squared plus 8x plus 12, and this would say factor. So we're going to factor this. So my first step is to list my factors of c. So c equals 12. So all of my factors of c could be 2 times 6, negative 2 times negative 6, 3 times 4, negative 3 times negative 4, 12 times 1, negative 12 times negative 1. But what I'm looking for are factors that are on this list that are going to add up to my b value, and my b value is 8. So here's the factors of c. There's lots of factors of c, but which ones add up to 8? And the ones that add up to 8 are 2 and 6. So now I'm going to make my parentheses, and this is when I think backwards FOIL. So I had to go first to get x squared. We had to have something times something gave me my x squared. That was what was in my first. Well, what times what gives me x squared? That's x times x. So I know in these first spots I'm going to put x times x. I know in my last spot, right here, to get that 12, I went 2 times 6. So I went 2 times 6, and that gave me my 12. It could have been any of these numbers here. But I also knew that my outer and my inner had to add up to be 8, because my b value is 8. And the way that the outer and the inner add up to 8, well, that's 6x, that's 2x, and 6x plus 2x does give me 8. So when we looked at our factors of 12, because it could have been any of these last factors to get to that 12, I had to find the ones where the outer and the inner would add up to 8. And that just so happened to be 2 times 6. I can check my answer then by FOILing. This is my final answer. This is the factored x plus 2 times x plus 6. Now it doesn't matter whether I put my 6 here or my 2 here, because I can use commutative property. Well, let's go ahead and FOIL it. Well, x times x gives me x squared. That gives me 6x for outer, 2x for inner. Those add to give me 8x. And last gives me 2 times 6. That gives me 12. Hey, it checked out. So let's take a look at another example. This would say factor. And so you're going to factor x squared plus 4x plus 3. So first thing I'm going to do is list my c value. That's 3. Factors of 3 are 3 times 1. I also could have negative 3 times a negative 1. I list my b value. That's 4. I want to find the factors of c that add up to 4. So that would be 3 and 1. I'm going to put my parentheses. I know to get my first, I'm going to have something times something is x squared. So that's x times x. My last has to be something times something to equal 3, so that's 3 times 1. But that something times something also needs to add up to 4, and so 3x and 1x does add up to 4x. I can check this out by foiling. So x times x gives me x squared. Outer is 1x, inner is 3x, last is, oops, this should be a 3. So that gives me x squared plus 4x plus 3. Here is another example, x squared plus 7x plus 12. I list my factors of the c term, which are 12, so that's 12 times 1, negative 12 times negative 1, 3 times 4, 2 times 6, negative 3 times negative 4, negative 2 times negative 6. My b value is 7. So I look at this whole list and I say, what values here add up to 7? And that would be 3 plus 4. Now, if you see that value right away, you don't have to make this whole list. If I had caught this on the second one, I could have just forgotten doing the whole list. You just need to find the ones that are going to add up to your b value. So that would be 3 and 4. So here I make my parentheses. X times x will give me x squared. 3 times 4 gives me 12. And 4x and 3x gives me 7x. So I checked it. Now let's take a look at another example. Here I have x squared plus 6x plus 7. And I list my factors of c, which is 7, so that's 7 times 1, or negative 7 times negative 1. Which of these add up to 6? Well, I can't mix and match. I can't say 7 and a negative 1. It either has to be 7 and a positive 1, or negative 7 and a negative 1, because 7 times 1 gives me 7, and negative 7 times negative 1 gives me 7. But I can't say 7 times a negative 1, because that would give me a negative 7 here, and I don't have a negative 7, I have a positive 7. So I notice 7 times 1, well, 7 plus 1 would give me 8, not 6. Negative 7 plus a negative 1 would give me a negative 8, that's not 6. So what I notice is that there isn't any that work here. And so what I can say about this trinomial is that it cannot factor. Now let's take a look at this problem. And this problem's a little different because I no longer have an a value that is 1 here. Instead, I notice I have a 2. So whenever you have an a value that is not 1, the very first thing you want to think of is, can I factor out a greatest common factor? And it just so happens that I can. So I factor out that greatest common factor. When I factor out the 2, I'm left with x squared plus 5x minus 14. So I now have this. I'm not finished. I'm going to look at this and say, can I factor this trinomial? Now my a value is 1, my b value is 5, and my c value is a negative 14. So I'm going to take my c value, which is a negative 14, and I want to find the factors of a negative 14 that add up to my b value, which is 5. And what I notice is that 7 times a negative 2 will multiply to be a negative 14, and 7 plus a negative 2 adds to be 5. So I'm going to leave that 2 there, but then I'm going to factor this trinomial. And that factors out to be x times x gives me x squared, and 7 times negative 2 multiplies to be negative 14, and negative 2x plus 7x gives me 5x. So I can check my work by foiling. Right there, I just foiled that back out. But now I'm going to take this 2 and use distributive property. When I multiply that out, I get 2x squared plus 10x minus 28. And now here's one more example, and I notice this is x to the 4th plus 2x squared plus 1. So my c value is 1, that's going to be 1 times 1, and my b value is 2, so 1 plus 1 does give me 2. But I notice, hey, there's something different here in the front. How am I going to get x to the 4th? And x to the 4th is made by going x squared times x squared. So my first is now going to be x squared times x squared. And then here I will put plus 1 plus 1. I can check my answer by foiling it back out. X squared times x squared gives me x to the 4th. X squared times 1 gives me 1x squared. 1 times x squared gives me another x squared. So those will add, outer and inner will add up to be 2x squared. And 1 times 1 gives me 1. So it does work when I foil it back out.